Okay, class. So 9 of you here. Yeah. Okay, 11. Good. Okay, class. Good morning. So today we're going to start with the continuation of superposition. Okay. So I think yeah. So what we done so far about superposition? Try to recall back. Okay. Sorry, I go to the PowerPoint. Okay, everyone can see the PowerPoint. Yes. Okay, good. Hey class, so what did you learn last class? So you learned about something called, so I just go through fast. We learned about diffraction, the spreading of wave pass through a slit, and we talk about double slit. Okay, before we talk about double slit, we talk about in depth about what is coherent, what is path difference. Coherent source, two source need to be coherent if they have keyword is what? Constant phase difference. Is it coherent source affected by amplitude? Let's say two sources have a constant phase difference, but amplitude is different. Is it coherent? Like for example, you have one wave like this. You have another wave. You have another wave like let me show you. You have another wave like this, but smaller wave, smaller amplitude. But the peak to peak, the separation is always the same. Further also, like I check the peak to peak is always the same. So it has a constant phase difference. Phase difference constant, but amplitude is different. Constant phase different, but amplitude different. Is it coherent? No. Yeah? No. No, it's coherent. It's coherent. Okay. It's coherent. Coherent, nothing to do with amplitude. Okay, you can have different amplitude.
Oh, that's observable interference.
That's observable. But for the coherent source, it can have a different amplitude, but as long as phase difference constant is coherent. Okay, path difference is what? The differences in the distance traveled for the two wave to meet the point. Okay, then we talk about condition for observable interference. What is the first thing? The source must be coherent. Second, they must roughly the same amplitude. Third point, not that important. I think not in your syllabus. Fourth point, they must meet. Okay. So what is the condition to have a observable interference pattern? The two path difference, the path difference between two sources must be in order of what? In order of n lambda. I show you this. It should be in terms of n lambda. N lambda. Okay. So next. Yeah. Any question?
For this slide.
Yeah.
If one of the wave start with true first, will the observable interference still occur?
One is start with true.
Yeah, another with cross, but still phase difference.
Okay, good question. Okay, let's see. You're asking like this. You have a two source. Okay, you have two source. So this is the screen. You see, one start with crash, another one start with true. Yeah. Right? So you said, is it going to be observable interference pattern? Okay. So you see, if these two coherent, means, if this is start with crash, this is starts with true means, when come to the center, is it going to be bright or dark at the center? Center, what is the path difference? Center, let's say this travel for 3 lambda means, this travel 3 lambda means, this also will travel, what? This also will travel 3 lambda, right? So this makes 1, 2, and 3 wave. So what is meeting at the end is a true. For the second one, start with true first. So 3 lambda, 1, 2, and 3. So what happened? What is at the end? Is it a constructive interference or destructive interference? Destructive. So what's the difference going to be? So center, which always normally is bright, because we are considering like this is crash, this also crash. So center always form bright. Okay. But this case, if this one crash, one is true. Okay. at the center, instead of bright, it's going to be dark. So wherever the bright happens, it's going to be dark. Wherever dark happens, it's going to be now become bright. But it's still going to be observable. Still will be observable. The point where the dark happens, going to be always dark. It's going to be always dark. Okay. As long as they are coherent, you will get to have a observable interference pattern. The only difference is what? If this start with crest, this start with trough. The true only difference is what? The bright spot become dark, the dark spot become bright. That's it. You understand?
Yes, thank you, teacher.
Okay, good. Okay, good. So, but for time being, we assume like both are start with crest, start with crest, so center will be bright. Center will be bright. Okay. So let me clear this. Okay. So now you see condition for minima. Now minima. Minimum is dark spot. What is the condition to have a minima? So the condition for a minima obtained when the path difference is half lambda, 3/2 lambda, 5/2 lambda. Okay, it could be half lambda, 3/2 lambda, 5/2 lambda. Why half lambda, 3/2 lambda, half lambda? Okay, let me go back to the whiteboard just to explain you detail. Okay, this is the yesterday's one. Okay, you see here. Okay. Okay, you see, let's say you have a double slit again. You have a double slit. So center, this start with crest, this start with crest. If they never tell, we assume it's crest. Okay, so the center point will be bright. Why? The path difference. The path difference is found to be 0 lambda. So it's a constructive interference. Okay, so we assume this 1, 2, 3 wavelength. This also like 1, 2. Should be 3 wavelength reaching here. But now let's see go for a further down up. Let's see go to the point somewhere here. Okay, this wave maybe travel 1, 2, 3 lambda still. But you see the second source. Is it going to travel the same distance as the S1 or longer than the S1? You see, longer than S1, right? Because this spot is a bit higher. On the top, located on top. So S1 is quite close. So S2 is a little further. So at S2 won't travel 3 lambda. You have to travel more lambda or less lambda. So it will travel more lambda. Okay. So it might travel 1, 2, 3. Let's say travel exactly another half. So what happened here? The trough meet with crest. So it forms what spot? This is going to be a perfectly dark spot. It's going to be a dark spot. Okay. So tell me, what is the condition to have a dark spot? The path difference must be how much? The path difference must be how much? This travel 3 lambda, this travel 3.5 lambda. Then only the crest will meet with trough at the end. Okay, see, another extra half is going to be a crest and here trough. So the path difference must be what? To have a dark, must be half lambda. Half lambda is a destructive interference. It's a destructive interference. So at the bottom also you'll get a dark. Bottom dark happens. The bottom dark happens is when now S2 maybe travel 1, 2, 3 lambda. Okay, but S1 going to travel further. S1 now going to travel further. So it might be 1, 2, 3. It should be extra half. It have to travel extra half. So the cancellation happens, forms another dark again. So here also the path difference will be how much? The path difference will be again half lambda. Half lambda. Destructive interference. Okay. Okay, now tell me. After dark, you go further, you get a bright again, right? You get a bright again. Why? So you must imagine lah. You must imagine. I already told you bright. So now what happened? This wave maybe travel, this S2, let's say travel 3 lambda again, 2, 3 lambda. But the S2 going to travel how many lambda? Anyone? How many lambda to get this first bright? This is called first bright. Anyone? The S1 should travel how many lambda? Should travel more than 3 lambda or less than 3 lambda? Should be more, right? Because S1 is further away. S2 is quite close to this spot. So how many lambda it should travel S1? Anyone? Anyone? How many lambda it should travel? First bright. First bright, it should travel 1, 2, 3, but extra distance is have to travel another 1 lambda. It have to travel another extra 1 lambda so that the true meet with true, so it become a bright spot. So the path difference for this bright will be what? For this bright will be path difference for this bright will be 1 lambda. 1 lambda. So conclusion is all the bright, second bright will be path difference will be how much? Anyone? Will be 2 lambda. The third bright will be what? Path difference will be 3 lambda. That's why I say it's n lambda for the bright. For the dark, come on, tell me for the dark. So the dark, the first dark is found to be, the first dark here is found to be half lambda. Okay, can you tell me? This is the first dark, this is the center, zero bright, first dark. Can you tell me second dark? What is the path difference will be? Anyone? How many lambda?
1.5.
Over 2.
Yeah, 1 over 2. 1.5 lambda you have to travel. So that means the condition to have a dark should be not of half lambda, 1.5 lambda, it continues 2.5 lambda, and so on. This is the condition to have a dark spot. This is how the wave traveling. You have to visualize like this, the wave traveling. Any questions so far? This part? Okay, I hope you understand. Okay, so let's move on. Okay, so this part. So there's a condition. So the condition to obtaining a minimum is the minimum also obtained as a 3 over 2 lambda, 5 over 2 lambda, and of course the beginning is half lambda, and half 3 over 2, 5 over 2 lambda. So the common term is to have a path to have a minimum occurs is n minus half lambda, where n is start with 1. Okay. Sometimes some books they put this common equation as like this. This common equation they put like this. This also can. They put n plus half lambda for the minima, but n start with what? Anyone? N should start with 0, 0, 1, 2. If n plus half lambda, when you substitute n as 0, okay, so it's going to be path difference still half lambda. So 0, 1, 2. If you use n plus half lambda, if you use n minus half lambda, n start with 1. Okay, you put 1, then you go get half lambda. But whatever it is, the first dark will be half lambda, the second dark will be 1.5 lambda, and so on. Third dark will be 2.5 lambda. Okay, good. So this is a condition to have minima and maxima. Okay. So result, constructive interference and destructive interference. Constructive interference, the two waves superimpose in phase, their amplitude reinforced, building a wave with a greater amplitude, of course, greater amplitude. The path difference will be, now it's something new now, the path difference will be what? In order of n lambda, 1, 2, 3. First bright, 1 lambda, second bright, 2 lambda, and third bright, 3 lambda. Okay. And the phase difference, the path difference, if the path difference is 1 lambda means 1 lambda equals to what phase? 1 lambda equals to what phase? Let's say the circle, you remember the phasor diagram, we call it this as a phasor diagram. I never mentioned the name. The name is like actual name is phasor diagram. Phasor diagram. You can check in the net. If this entire particle A, B, C, D, and the E placed in this circle, so this is going to be A, this is going to be a B, this is going to be a C, and this is going to be a D, and yeah, it's going to be a D. Oh, sorry, something. Yeah, okay. Yeah, sorry. So this is going to be a D, this is going to be a D. So for one wavelength, what is the phase difference? The phase difference is 1 round one. So one wavelength, the phase difference is 2 pi radian. It's 2 pi radian. So path difference can link to phase difference if 1 lambda, 2 pi radian, 2 lambda, 4 pi radian, 3 lambda, 6 pi radian. Path difference linked to phase difference. Okay. So for destructive, of course, they cancel, n minus half lambda, and the phase difference is half lambda. Half lambda is pi, 1.5 lambda 3 pi, 2.5 lambda is 5 pi. In terms of phase difference. In terms of phase. Any questions from this slide? Okay. Okay, so we proceed. Okay, so now your turn. Okay, so some questions first. What does it mean by two coherent sources? The two sources say to be coherent if they have constant phase difference, not varying with time. Eventually, the frequency must be the same. Amplitude is okay, can be different, it's fine. Okay, two, why coherent sources are needed? Anyone? Why coherent sources are needed? To have a observable interference pattern, so that we can see the pattern. So yeah, to produce a steady interference pattern, the maximum intensity, minimum intensity regions are not changing. As I told you last time, if your house now you got two light, why you can't see the interference, although interference is happening because the two sources are not coherent. Because the point where the bright happens, immediately few milliseconds the bright become dark, because phase of the phase of the two sources are keep on changing, keep on changing. So of course, coherent source needed to have a observable interference pattern. How to produce coherent source? This is I never told you yet. Okay, so if you have two light bulb, if you go to the screen, you can't see the interference pattern because we don't know when the electron going to go down. This electron go down and this electron go down. They are totally random. So this wave start with time. This wave take a little time later, then only it start to come out. So the phase will be different. Okay. So how to have a constant phase difference? Coherent source. So instead, you have two source. Anyone? Use source same frequency, or
okay, one slit.
once you just use only one source. You just use only one source, but double slit after that. Only one source. That means the electron goes down. You give up rays pass through this slit. The same ray pass through this slit, but the two rays are coherent because these two rays are formed from the same electron coming down because only one source. Then it will be coherent. And a light source with a narrow slit to get an emission of light from electron at one time, followed by a double slit to get two coherent sources. So instead of use two light bulbs, use only one light bulb and have a double slit after that. And yeah, this one source become two separate sources. And of course, this S1 and S2 is coherent because it's originated from one single source. One single source where the electron comes down, the wave going to be coherent. Okay, the wave going to be coherent. Okay, any questions from here? Okay, okay, so let's read. Okay, so what's the answer for this? The two graph above, is it coherent? The red and the blue, the two waves, is it coherent? The waves are coherent, the waves are incoherent. What is the best answer?
B.
B, yes, it's coherent. It's coherent because you see the crest and the crest separated, the phase difference, and you see the crest and crest here separated. The phase difference is the same. The separation is the same, so it's coherent. It's definitely coherent. It's coherent. Okay, but out of phase, there is a little phase change, phase difference. So answer should be B. Should be B. Amplitude difference doesn't matter. Amplitude nothing to do with coherent. Okay, so B is answer. Okay, so what does it mean by monochromatic source? A type of source only made of single frequency. It's called monochromatic source. Normally, a laser pointer is a monochromatic source. Laser always made of one type of wavelength. So it's a monochromatic source. Now you are sitting your light. Is it your light bulb you are having in your house? Is it a monochromatic source? It's not a monochromatic source, right? Because it give out white light made of how many colors? 7 wavelengths, right? So it's not a monochromatic source. Monochromatic source means made of one single wavelength. Okay. Okay. Condition for two wave to interfere. The two wave must meet at the same point. the two wave must be same type. Must be the same type. I told you this. And third point, not that important now. Just first two. Okay. Condition to obtain observable interference pattern, we already done that. Must be coherent source, must be same amplitude to have a good contrast. And yeah, a large distance between the source and the screen, large spacing between the fringe can give more better observable interference pattern. But I tell you the third point later after you see the formula. Okay. So young double slit experiment, I believe you come across this formula before. I don't know about O levels. So this is the formula linked to double slit. Okay, linked to double slit. So you have to know what is X, lambda, D, and A represents. Okay. So what is X? X is a fringe separation. X is a fringe separation. What is fringe separation? The bright, the dark to dark, the consecutive dark to dark, or the bright to the consecutive bright spot is X. It's called fringe separation. Let's say you got a bright spot here, then you got a bright spot here, okay, then you got a dark here, this is dark. So dark to dark consider as X, or bright to bright, the center bright is considered X. Okay, X. So it's fringe separation. X is fringe separation. Okay. Lambda, you know, is a wavelength of the source. What wavelength comes in? D called distance between source and screen. Okay. Where's your source? Not the single source. The source is considered from the double slit. So this is your source from the double slit to the screen. This is your D. Okay, this is your D. Okay, don't go to the single source. The double source is considered the original, the actual source. Double source, two sources. So D is from the double slit to the screen. Is your D. And distance between the source and screen. A is a slit separation. Slit separation. So these are the slit here. Okay, let's say you have two slits. Let's say you have two slits. Here one slit, and you have another slit. Slit separation from the center to center here. That's called slit separation. A. That's your A. Okay. So the derivation of this you don't need to know. Lambda equals to AX over D. If I want to rearrange it back, rearrange it back. Okay. Okay. So what is the purpose of double slit experiment for us? What is the use of double slit experiment for us? Anyone? What this double slit gives us? What information the double slit gives us? Useful information. Anyone?
Light interacts as a wave and a particle, like that.
Okay. Yeah, that's under quantum later. But by doing double slit experiment, we got a very important information about the light, the wavelength.
Okay.
You can calculate the wavelength. Yeah, just now your theory, the 3D light, the 7 light colors. What is the wavelength? Would be 400 nanometer to 700 nanometer. It's too small, you know. Naked eye we can't see it. But how are scientists able to measure is it 400 or 700? So they pass through the light through the single slit, double slit, and they measure the D, X, and A. Then they calculate the lambda. Okay, so lambda able to found by using double slit experiment. Okay, so the use of double slit is just to find the wavelength of any type of light. You just pass through the double slit, you can calculate the wavelength by using X equals to lambda D over A. Okay, you can find the wavelength. So the use of double slit is to find the wavelength. Okay. Okay, if the two sources at the same amplitude, so bright become 2A. Okay, bright become 2A, and the dark becomes 0. Perfect cancellation. Okay, so you get like this. You get like this. Okay, the second one is one source is 2A, another one source is A. What I'm trying to tell, you have a double slit. Okay, one source is 2A, and this is 2A. another source is A. So what the problem you face on the screen? The center bright will be amplitude of 3A. The dark spot will have an amplitude of 2A. Won't perfectly cancel. You will have 1A. So it will be a little bright, a little bright, a little bright. So what is drop? The contrast drop. That's what you see here. You see here the dark spot not very clear, not very clear. But here you see this one is good. The dark lines are quite clear. The dark line because it's a cancellation effect. So 1 or 2, which preferred in the double slit experiment is 1 or 2. The 1. Why the 1 preferred? Because you can see the dark line quite clearly, so you can measure the x quite clearly. Okay. So why you need to measure the x? Because we want to work out the wavelength. Wavelength is ax over d. So if you measure the x accurately, you can measure the wavelength accurately. Okay. Okay. So this 2A, and bright cancellation and so on. Yeah, skip this. Okay. So this is another important section. Okay. Now the formula is what? The formula is lambda equals to ax over d. Lambda equals to ax over d. Okay. Now we want to see what are the effects given when the parameters are changed. Some parameters are changed. Okay. What happened to the interference pattern? Any changes to the interference pattern? Is it the x get longer or shorter? Mainly about x lah. Is it increasing or decreasing? And explanation for it. What happened to the x? What happened to the contrast? This is our main concern. When the parameters has changed. Okay, the first parameter we want to change is L. Okay, what is L? The symbol is different, but actually in this case the L is the D. The distance L is increased. Actually, you can cancel the L. You can put it as a capital D. Okay. The first one is when the D increased. What type of change happened to the interference pattern? What change will happen to the interference pattern when the D is changed? Okay, so let me draw. Okay, what I'm trying to say is yeah. Okay. So you see here, you have double slit. This is your A. Okay. This is your screen here. You got a D. Sorry, this is your D. This is your D. Slit separation. And of course, the bright. Let's say appears here. This is your X. This is X. Now the question is, the D is increased. The D is increased. Okay, the D now increased to a longer one. How did it increase the D? The screen was shifted back. We place the screen now here. What type of change will happen? What change will happen?
X increase.
Yes, good. The X will increase. The bright spot will get further. Okay. Why get further? You see, this is the light source. This is the light source. Okay, this is the light source. Or you can check from the formula itself, lambda equals to ax over d. Okay, ax over d. So you see, make the x as a subject. X equals to what? Lambda d over a. So when the d increases, mathematically the x should increase what? X should increase. So x increases. That's the first appearance. Okay. So that's the first thing. So what happened? The x increases. X increases. What is the x increases because x proportional to d. As I told you, the L you take it as d. The L you take it as d. Okay, L you can take it as d, capital D. So this is d. Yes, x proportional to d. How? Lambda equals to ax over d. So x is lambda d over a. So we found x is proportional to d. That's the explanation. Okay, now second. What happened to the contrast? Contrast looks like poorer, very bad contrast. Why? The reason given is the intensity is directly proportional to 1 over d squared. This you learn in your wave data before, right? I intensity is proportional to 1 over d squared, inversely proportional to the d squared. Correct? So you have a source here. Okay, you have a source here. You have a source here. Okay, and the distance, the screen distance was moved back. So the d get longer. Imagine the wave have to travel further distance. You have to travel further distance, greater distance. So what happened to the intensity when you reach the screen? The intensity going to drop. The brightness going to drop. That means the bright spot become dimmer. The dark spot, what happened to the dark spot? The dark spot remain. Don't say the dark spot get dimmer. Dark spot, nothing there. So dark spot remain. The bright spot getting dimmer. Okay. So in appearance, bright get dimmer, dark remain, bright get dimmer. So what happened to the contrast? Bright get dimmer. So contrast become lesser. So that's the reason for second one. When the D increase, when the screen was placed further, the X increases from the formula X proportional to D. Contrast get poorer. The reason is the intensity is proportional to 1 over D squared. So therefore intensity of the bright spot drops, dark spot remain. Therefore contrast get poorer. You know, in exam, past year question, they ask about contrast. They give 3 marks, 3 marks to explain it. When the D increase, what happened to contrast? 3 marks question. So how do you get the 3 marks? First mark student get when they say contrast poorer, 1 mark. The second 2 marks they get it is the intensity is proportional to 1 over D squared, 1 mark. Then the third mark they get by telling these two. The bright getting dimmer, the dark remain. For these two, they get 1 mark. Okay. So whenever they talk about contrast, you have to talk about what do you call the bright and dark spot law. What happened? Okay. Okay, so you got idea. Okay, any question for the first part? So reasoning you have to remember. Okay, now go for the second one. Slit spacing D increases. Slit spacing. Okay, slit spacing D increases. Lambda increases. Width of the slit increases. The slit spacing. Here the D is actually imagine like your A. Your A is the slit spacing. Slit spacing increases. That means the two slit, the separation was increased. What will happen to the X? Mathematically check what happened to the X. X is lambda D over A. When A increase, what happened to X? Mathematically, the denominator increase, X will
Decrease.
X will decrease. Good. So yes. So X will decrease. X will decrease. The reason again, quite convenient for us, just rely to the formula. So X is inversely proportional to A, so X should decrease. Okay, so no problem explaining the X, but the problem is about contrast. What happened to the contrast? Okay, the contrast. The maximum brightness at the center drops, the contrast decreases slightly. Okay, the maximum brightness at the center drops. Okay, the maximum brightness at the center drops, the contrast decreases slightly. Okay, yeah, why is the maximum brightness at the center drop? Anyone? Because again, the distance traveled by the wave is longer now when reaching the center. Do you agree? When reaching the center. Okay, what I'm trying to say is, again the slide. Okay, you see here. Okay, so this is your A, short A. Okay, so center bright, the wave traveled from here to here. This is the distance t1. Okay, now let's say A is increased. A is increased. This moved here, and the other one moved here. Okay, now the center. You see the wave must travel this distance, t2. d2 should be greater than d1, right? d2 is greater than d1. So the wave traveling for the distance. Okay, for the distance. So the center bright, the brightness going to drop. Brightness going to drop. So brightness still drop, the dark still remain. So contrast drops. Okay, slightly, not much of a difference. Slightly. Why slightly? Because still the d2, d1. Of course, d2 is greater than d1, but not a big differences, not a big differences. But whatever it is, the contrast drops slightly. Okay, any questions from here? When you move the A up, the distance traveled by the wave to reach the center point increases. So we know that what intensity is proportional to 1 over d squared, and the distance travel is increases, the intensity going to drop, the bright spot going to drop slightly. Okay, hope you understand. Okay, so that's the second one. X decreases, maximum brightness center drops because distance traveled by the wave longer when reaching the center. Contrast slightly decreases. Okay, third point. Lambda increases. Lambda increases. What happened to the X? So go back to the formula. So when lambda increases, check the formula. Lambda increases, the X will increase, right? Lambda equals to AX over D. So X is lambda D over A. So when lambda and X is directly proportional, when lambda increases, X increases. The spacing between the bright and bright spot get further. Okay, that means use the red light, you get an X. Use the blue light, the X going to be shorter or longer. Use red, you get X 1 centimeter. Use blue light, the X will be smaller than 1 cm or more than 1 cm. Red big wavelength or blue more big wavelength? Blue shorter wavelength, right? Okay, so shorter wavelength will yield a shorter fringe separation. Shorter fringe separation. So when lambda increase, when lambda increase, X increases. How about the contrast? The contrast get poorer. Why the contrast get poorer when the lambdas increase? Okay, larger lambda, which is more comparable to the slit width, more diffraction. The reason is more diffraction. It spreads more, so intensity decreases because of diffraction more. Okay, as I told you, when a wave diffract, what happened to the amplitude of the wave when it passes the double slit? The amplitude going to drop. So when the amplitude drop, by the time it reaches the screen amplitude is even smaller, so the bright spot become even less brighter. So contrast drops. Okay, so when you raise the wavelength, the wave going to spread more. Okay, the wave going to spread more. Okay, hope you understand what I'm trying to say. Okay, again, just some of you which can't visualize it. So what I'm saying here is, so of course you have to and use a red light. Okay, it's a big wavelength. Big wavelength. Okay, if you have a big wavelength, let's say first use blue. Blue light. Let's say it spreads little. The wave spreads like this. Okay, this is where the interference happen. Okay, so now let's say you change to red. You change to red light. Red light, when it passes through the street, it's going to spread more. The red going to spread more. The red going to spread more. So because it spreads more, the amplitude of the light becomes smaller. The amplitude is getting smaller because when something diffract, the energy is spreaded, the amplitude drops. So therefore, by the time reach here, the bright spot get less brighter. So contrast decreases. Contrast decreases. So conclusion is, wavelength increase, diffraction is more significant. Diffraction increases. So bright spot dimmer, dark remain. So contrast decreases. Contrast decreases. Okay. Any question from here? Okay. So yeah. So that's the point. So when the lambda increases, contrast gets poorer. Larger wavelength will move comparable slit width, more diffraction intensity decreases. Okay, the fourth vector, the width of slit increases. Okay, what is the meant by width of the slit increases? Width of the slit means, okay, let me do here. The width of the slit is increases. Let's say this is your double slit. This is a double slit. Okay, the A, let's say, is 2 centimeter. The A is 2 centimeter. Okay, now they increase the width. This is your width. Okay, this is your width. This 2 is the width, the W. The width is increased. The width is getting longer, I mean greater, without changing the A. The A is still 2 centimeter. Okay, the A is 2 centimeter, but the width is increased. Okay, what will happen to the X? Anyone? When the width is increased, what happened to the X? Is it X affected by the width of the slit? So lambda equals to AX over D. So everything is in the formula already. X is affected by what? X is only affected by the lambda, the D, and the A. Do you have the width of the slit here in this formula? You don't have width of the slit. So X is remain unchanged. X not affected by width. The only factor can affect X is your lambda, your A, this is your A, this is your D, capital D. These three only, because in the formula only the 3 factor affects the X. So width does not increase the X, unchanged, but contrast get higher. Why contrast get higher? So this is the reason. When the X independent of width, white slit, that's why X does not affect. More light energy will pass through the intensity. More light will pass through the slit. The intensity increase, so less diffraction, intensity increases. Okay, means what? Okay, I need to show you this again. Okay. Okay, so when this is the original width, let's say spread like this. Okay, spread like this. Okay, when the width increased, okay, when the width is increased, getting bigger, so the amount of light source going to pass through the slit is a lot. Okay, and it's not going to spread like this anymore. It's going to spread lesser. It's going to spread lesser. It's going to spread lesser. Okay, spread lesser. That means the light are more focused. Okay, so the spreading is in other words, the diffraction is lesser. More light pass through the slit. Okay, so the amplitude get bigger. So therefore the bright spot become more brighter, the dark still remain. So the contrast we said increases. The contrast increases. Okay, why? And the width increases, the light won't spread a lot. It focus. Okay, if the light is focused, not spread a lot, the bright spot will be more brighter because light not spread. If light is really spread, the intensity drops, right? If the light spread only little area, the intensity is very high. So bright spot become very bright. The dark still remain, therefore contrast rises. Okay, so width increasing does not affect X, but contrast rise. Contrast rise. Okay, so that's the introduction of this. The last point not that important. Cover one slit, the interference won't happen. Broad bright fringe at the center, single slit diffraction pattern happens. Single slit not in your syllabus. So the fourth one, the last one, you can, if you want, you can check from the internet. They won't ask. What you can answer is when one slit is covered, no interference happens. No interference happens. Okay, only one source. Okay, any question about this diagram, this table? This is a very important table for you to explain. They'll ask you to explain about contrast and X. Okay. Okay. So interference also happens in sound. So if it's a sound, 2 light speaker is given as sound, the formula still works. Formula is still what? Formula still works. Formula is still lambda equals to AX over D. Here the A is what? Of course, again, from the speaker to another speaker is your A. These two are the sources. D is, of course, if you put L, but it's actually, according to the formula, we standardize it, is D. And you won't see a bright, dark here. What you're going to see here is the loud, soft sounds. The loud to loud sound is X, or soft to soft sound is X. So it still works sound, this formula. Okay, but to produce this experiment in sound, you need to have as a huge area without any building at the side. You can't have building at the side. Why? Anyone? If you have building at the side, what is the problem you're going to face?
Reflection.
Yeah, reflection going to affect the interference. You can't have the building at the side. So difficult to do this experiment by using sound. Reflection going to interrupt the interference. Okay, now you tell me what is the answer need to be filled in this table. Two speakers are further apart. Spacing between the two regions of X become shorter or longer. Two speaker. So A increases, right? A increases. So first case is actually A increases. When A increases, X will
decrease.
Yes, good. Second one, the observer walks further from the speaker. The observer walks further from the speaker. That means the D has been increased. That means he walks further from the speaker. That means the screen was further away. When D increase, X also will increases. Good. Low pitch sound is used. Low pitch sound. What happened to the X? Low pitch sound means indirectly they said what? The amplitude come out from the sound is lower now. So what happened to the X? Unchanged. Unchanged. It does not affect the X. Low pitch or high pitch does not affect the X. Low pitch means the loud sound will be slightly not that loud. That's it. Unchanged. Okay, so this the answer should be. Okay. Okay, so now we done with the, yeah. Any questions?
The pitch is affected by the frequency.
Pitch affects the frequency. Oh yeah, sorry, guys. I'm so sorry. I think I'm. Yeah. Sorry. Pitch affects the frequency, right? Low pitch means low frequency. So what happened? The wavelength gets
longer.
Longer. Yes, correct. I'm so sorry. The wavelength get longer. What happened to the X? X get longer. Sorry, X get longer. So pitch is the frequency. Intensity is the amplitude. Okay, good. Thanks. Okay, so now we're going to go back to questions. So we're done with the double slit experiment. Okay, double slit experiment. Okay, yeah. Another one question I would like to ask is, if you have a double slit experiment here, double slit, and you have a screen, okay, this start with crest, this start with crest, center form a bright. If this start with crest, this start with truth, what is the change to the appearance will happen? The bright become dark, the dark become bright. Okay. Okay. So what will happen to the appearance when you shine this double slit with the white light? What are you going to see on the screen? You shine with the white light. White light consists of 7 wavelengths.
Oh,
So center bright going to be what color?
it's not gonna produce. It's just white color.
So it's going to be white. Center will be white because all the wavelengths will meet up at the center with the 0 path difference. Then the first bright at the side, the first bright will be what? Will be in form of a spectrum. It shows the spectrum. Okay, the first bright will become a spectrum. Spectrum means the 7 color, the rainbow color will appear here. The most on the top will be what color? The top will be red or violet, away from the center. Red. Why red?
The wavelength is longer.
Wavelength longer, therefore
More diffraction.
very good, more diffraction. Red more wavelength, so diffract more is going to be further. So violet going to be the nearest last. So you're going to show a spectrum. Why it shows a spectrum? Because a different wavelength will make a bright spot at a different location because of the wavelength difference. Because first bright, the path difference must be 1 lambda. So 400 nanometer to 700 nanometer of 7 colors. The 400 nanometer path difference 1 lambda happens closer, nearer. 700 nanometer, the path difference, the 700 nanometer happens later, further away from the center. So you see a spectrum. Good, you see a spectrum. So down here also you see a spectrum. The closest is going to be violet, the furthest is going to be the red. Okay, why violet is earliest? Because as your friend said, it's a diffraction, less diffracted. Okay, good. Okay, so let's go back to some past year questions. Any questions so far? Okay, so just one question before not enough time. Okay, this past year, the first question, what's the answer? 28. 02, 28. Okay, you can WhatsApp me. Which equation correctly determines the position of x? So first, x is a dark spot or a bright spot? X, is it a minima or a maxima? They try to trick you with wording. X is minima or maxima? Anyone? Minima or maxima. The detector moves from O, the direction of the arrow goes up. The signal detected decreases until the detector reaches the point X. The point X, the signal decreases, the intensity drops until X, and then start to increase again. Detector move beyond X. That means X is the lowest intensity or the highest intensity?
Lowest.
Lowest intensity, minima or maxima?
Minima.
Destructive interference, right? So it's analog to dark. So X is considered the first dark. Okay, X is the first dark. Okay, so this is the first dark. This should know is the first dark. First dark, the path difference must be how much? Half lambda, right? The first dark is half lambda. So which is the answer? OX is half lambda or S2X minus S1X is half lambda? A or B? A or C? B and D cannot. Should be half lambda because it's a first dark. A or C?
C.
C, the path difference. Okay, the path difference. S1, S2, the differences should be half lambda. Okay, class. So I think time's up. Okay, you might have extra and other classes. So we stop here. Any questions? No questions. Have questions? Okay, so if you don't have questions, we continue tomorrow. Tomorrow. Okay. Thanks.